Imagine you are studying for a test and a few relatives come over. What do? It is safe to say that there are only two kinds of people in such situations. First are those who step out, greet them and have a pleasant time with the visitors. And the second ones are those who choose to study instead because they can catch up with visitors anytime. Let's say there are some who meet people and some who avoid people. Similarly, math also has intervals of two types, one that includes and the other that does not include. Keep watching the video to learn more about intervals as subsets of real numbers. A set is a well-defined collection of objects. You might be familiar with various sets like a set of natural numbers, a set of whole numbers, a set of integers, a set of rational numbers, a set of irrational numbers and a set of real numbers. Set A is said to be a subset of set B if every element of A is also an element of B. In the language of set theory, this can be written as if A is a subset of B and also if element small a belongs to set A, it implies that element small a belongs to set B as well. Let us have a look at some well-known sets and their subsets. Let us go back to the number sets we started with. You might be familiar with the number line representing the set of natural numbers. When we add 0 to it, we get the set of whole numbers. Now, if we add negative integers to it, we get the set of integers. All these sets are subsets of the set of real numbers. But does the set of real numbers include only these numbers? No. There are infinite rational numbers and irrational numbers between any two integers which are also real numbers. Not just between any two integers, between any two real numbers A and B, there are infinite real numbers. The set of all real numbers between A and B is called an open interval and is denoted by curved brackets A, B. All the points between A and B belong to the open interval A, B. But the end points A and B do not belong to this interval. On a number line, this can be shown with open dots at the endpoints. For example, the open interval 3, 5 has all the real numbers between 3 and 5, excluding the endpoints. Can you identify the set of numbers that is denoted by the open brackets minus infinity 0? Yes, this is the set of negative real numbers. What about the set of all real numbers? Yes, they can be shown as an open bracket minus infinity, plus infinity. Now, similar interval that contains the endpoints also is called a closed interval and is denoted by square brackets closed interval A, B. That is, all the points between A and B, including the endpoints, belong to the closed interval A, B. On a number line, this can be shown with closed dots on the endpoints. For example, the closed interval with closed brackets 3, 5 has all the numbers between 3 and 5, including the endpoints. An interval can be semi-open too, that is, open from one side and closed from the other. A semi-open interval can be represented using a curved bracket on one side and a square bracket on the other. As the definition suggests, the endpoint at the closed side is included in the interval and the endpoint at the open side is excluded from the interval. That is, a semi-open interval with a closed bracket to the left and an open bracket to the right, A, B, would have all the real numbers greater than or equal to A and less than B. Similarly, a semi-open interval with an open bracket to the left and a closed bracket to the right, A, B, would have all the real numbers greater than A and less than or equal to B. On a number line, this can be shown with an open dot on one side and a closed dot on the other. For example, the semi-open interval left closed right open bracket 3, 5 has all the numbers greater than or equal to 3 and less than 5. Similarly, the semi-open interval left open right closed bracket 3, 5 has all the numbers greater than 3 and less than or equal to 5. The length of any type of interval, be it open, closed or semi-open, can be calculated by taking the absolute difference between the endpoints. That is, for all the 4 intervals, open, closed or semi-open, 3, 5, the length of the interval is the absolute difference between 3 and 5, that is 2. Let's summarize what we've learnt in this video. The set of all real numbers between A and B, excluding the endpoints, is called an open interval and is denoted by open brackets A, B. The set of all real numbers between A and B, including the endpoints, is called a closed interval and is denoted by closed brackets A, B. A semi-open interval can be represented using a curved bracket on one side and a square bracket on the other. It can be denoted as left closed right open bracket A, B or left open right closed bracket A, B. The length of an interval can be calculated as the absolute difference between the endpoints. Now that you know the different types of intervals and how they are used to calculate, do you know what the applications of the 2 types of intervals are? Await our upcoming sessions to learn more.
Keep imbibing. We believe in you.